This is the knife that's breaking the internet right now. There's a very small YouTube channel called Knives, I guess. He got 22,000 people watching him live stream for 8 hours straight as he used his knife to cut cardboard with a single edge without doing any sharpening on it. 8 hours straight of that. And yet, people care about this knife that much. It is that good. Why? What makes it so special? Well, it's got D2 tool steel. That's the primary feature. D2 is the best material for a knife blade. Of course, there are certain situations where another material would be more suitable, but by and large, D2 is the best. It's got a ball bearing pivot, which makes a completely smooth motion to open and close it, and it's got a slide lock. All those features, you used to have to spend $200, $150 to get. Now you can get this one here at Walmart for $10, under $10. Thank you, Chinese slave labor, for giving us awesome stuff for very little money. But as cool as it is, I hate the scales. I don't like the orange color. The texture isn't that great, and I think I can do better. Which, if you saw the last video about my new laser cutter here, you know that I did make some pretty cool scales out of my old jeans. I laminated some swatches of the jeans together using some epoxy resin, and these are quite nice. I do like them, but I was convinced that I could do better using a 3D printer in combination with the laser cutter. So I did some more work in CAD, and the result is just fantastic, you guys. It was so good that I had to make a video all about it. Let's talk about the process to get here, and really I want to show you guys and inspire you to start drawing in CAD, because if there's nothing else that you get from my videos, be inspired to do this kind of work. You can learn CAD and you can make something like this that looks better than the thing that you can buy. Before we jump into CAD, let's survey the project thus far and see what progress I've already made. When you go to buy the knife in store, see if you can get a look down the blade. Maybe you can see if it's bent. And now it's not going to be bent. It's going to have an uneven grind, so they will have taken off more material on this side than on that side, and so when it sits in the scales, it will be asymmetrical. It'll sit off to one side, but it'll still be perfectly functional in D2's tool steel and all that. So, you know, that's the risk you take buying a $10 knife, even though it's very high quality otherwise. So these are the scales that come on the knife, and if we look on the inside, we can see these ribs for structure, but more than that, those are meant to give the injection mold a thinness, because if you injection mold a single solid piece of plastic, the plastic will shrink during cooling and you'll end up with strange, ugly pockets. So don't want to do that, and that's why this is designed like it is on the inside. But these pockets here are to give clearance for the spring that sits right there along the crossbar lock. Now that's also called a slide lock, crossbar lock. Those are the two terms for that. So I didn't like these scales. Like I said, they're not very grippy, even though you can see a crosshatch pattern on them. It doesn't do much, and they're orange. It's really ugly. By the way, some guys are selling for $27 eye-dyed, like just plastic dyed orange scales. So now they're black, and they do look much better than the orange in my opinion. But you can get a packet of this for something like $6, and I mean, the whole knife costs $10, so there's your $16, and you know, $27 seems like a lot of money. About that $27 dyed knife on eBay, that's the current bid, and there's 3 days left in the auction, so it's probably going to go for a lot more than that. The other auction here has a buy it now for $45 delivered. That's, you know, a lot. $10 knife for $45. If you want to buy just the orange scales, you can get this one here all day, every day for $40. And there was one that sold during the course of making this video here for $22. You can see this listing is already sold. So yeah, it's a popular item for sure. But all of this scalping on eBay is just a result of the temporary scarcity of inventory in stores. You can see it costs $10 if you can just wait for it to come back in stock. Walmart has committed to carrying this item for the long term. This isn't a temporary limited time offer. So just give it a couple of days and it'll be back in stock. Anyway, these are the first scales that I 3D printed. They are very functional. They feel great. We'll talk about that here in a second. But I didn't like the crosshatch pattern. You can see it sort of bends. There's sort of a constant movement to it. And I wanted it to be sort of more regular all the way across. So I did some magic in my CAD program to, it's called the U and V of the surface, and I had to get the U and V regular, rebuilding the surface there. And that's what I came up with. So you can see the very regular crosshatch, gorgeous. This feels amazing in the hand. This is carbon fiber PLA filament, and it feels like sandpaper or grip tape from a skateboard, but it's not as harsh on my hands. Like, it's not tearing up the grip, the pads of my fingers. And that's just incredible. The reason it does that is because I printed these at 0.1 millimeter layer heights. So it's printing like this, and there's a roundness to this, plus each one of those little cross hatches is an island sticking up. And so the layer lines interface with the grooves in my fingerprint, and just, there's no slipping on that. But it doesn't look quite as nice as it could. It looks nicer than the orange, to give you an idea, but I like the version here the best. And this is what you saw me showing off in the intro. It is a sticker. That's this stuff right here with this sort of felt cloth that's been rubberized. Like, they put a rubbery coating on it, and it's got the crosshatch pattern already built into this stuff. So I got that on Amazon. If anybody wants to get some of that, there's your description. Go looking for that. I don't know where the link is, and I have no affiliate link for that. So buyer beware. Do your own research there. But yeah, this just looks incredible. How are you going to cut out a complicated sticker like that with a knife? I guess you could print it onto a piece of paper and glue that paper to the back of this and try to cut it out. You could do it. Wouldn't be quite as clean as what I achieved, but that's because I now have a laser cutter, and I'm stoked on that tool, by the way. Watch the video in the description. Yeah, laser cutters are awesome. So that's how I was able to make that, and I'm just tickled. This looks professional. This looks like it came straight out of the factory to me, and it is absolutely the most grippy, comfortable, and ergonomic design that I've come up with. Absolutely the best. So I'm going to run with this and keep working on it. Although this is a close second, and I'm going to say the durability here is higher, and the grip is a little bit higher as well. So if you just want a very tough knife that's going to go the distance, this is probably your better thing. And back to the original, project here, using the laser cutter to make these denim micarta scales. These are great. They feel really comfortable. They feel like denim. I can feel the ridges after sanding it, and you can see they look like denim. They look like dirty jeans right here, which is, pretty cool, right? Upcycled, and I like it. But now that I've done other things, the first idea is never the best. It is cool though, and this is going to be the toughest material for sure. So I'll probably keep this around just because I worked so hard on it, but maybe I'll get a third knife, because what I'm going to make right now in CAD is a left-handed version of this, which also receives the belt clip, because my dad is left-handed, and this knife does not come with a left-handed variant. You can't switch the clip here to the other side unless you 3D print it. This is my CAD platform. It's Rhinoceros 3D version 8 at the moment, and I love this program. I've tried to use a couple of others. I started to get familiar with them, and I always come back to Rhino. It's just the best for the work that I do. It's not the best for everything, but it's a really great program, and it's not new. It's been around since the 80s, the 1980s. It was the original three-dimensional modeler for AutoCAD. They were in partnership with Autodesk back then, but they spun off on their own, and they have their own little niche. They're a wonderful company. The program is just the old license to buy. Like it's the old style of software licensing, which I love. It's just honest. So you buy the program. If you buy it right now, I think it's going to be like $1,000. But if you wait until the latest version comes out, so just be on the mailing list, as soon as that version drops, there's always a 50% off sale, and you can update the old version to the newest version for very inexpensively. I think I upgraded from 7 to 8 here for like $350. And unlike all the other softwares that you will use, they never do things to deprecate the old versions. So I can easily open up Rhino 7. I can save a Rhino 8 file as a Rhino 7 file. So the versions play very well with each other. It's just, the updates won't work on Rhino 7, so you have to move to Rhino 8. And I always happily give them my money every few years whenever they come out with a new version. So I really love the company and I really love the program. So there you go. But if you're going to be beginning CAD today and you've never done it before, you're probably going to start with Tinkercad and then move on to Fusion 360, which is an Autodesk product. And I don't love Autodesk. I'm not going to speak badly of them, but they do have a history of offering products and then taking them away, and you just can't access them anymore. Or they give Fusion 360 away for free, and then they start sort of ramping things up, and they make you pay. You know, if you use it too many hours during the day, they think you're a professional or something like that, and they make you start paying professional licensing. So none of that kind of behavior from McNeil and Associates. That's the people who make Rhino here. So anyway, let's look and see how I actually am going to do this project. I imported the photo that I took from across the room. So I have a 100mm camera lens on my fancy camera. You could use a cell phone camera and just zoom in, but you want to take it from quite a distance away because the farther away you are from the object, the less distortion you're going to get. And with a 100mm lens, I get a lot of. I could have been zoomed in a little bit more, but it's not a zoom lens. It's just a regular 100mm lens. So that should be a distortion-free photograph, which means I can draw a line from this little crosshatch on my ruler. Let's go right in the center, all the way to the crosshatch up at this end. And now that that line is drawn, I can scale it in one dimension so that I can click here and there and go to 30 centimeters, cm. So I'm typing on my keyboard and you can see it popping up here at the top. And this is a different interface from the so-called parametric modelers, which is what everybody uses. It has its benefits, but they're not as great as the marketing has led you to believe. Of course, everybody that uses them is familiar with them and they're going to love them, just like I'm very familiar with Rhino and I love it. So whatever you spend the hours to learn is what you're going to love, I think. That has more to do with people's preferred CAD platform than is it actually better or not. Anyway, now that I've got that line scaled, I'm going to select the actual photo and scale the photo based on that start point, which is on the 0 mark, and then up to here, right there, and then slide that to my actual 30 centimeters. So now that photograph is perfectly scaled into the CAD space here, and everything that I draw will be the exact correct scale to the real object. So this is a poor man's scanning technique, and another technique to get the same results is to use an old flatbed scanner. You can do something similar, but I've always got cameras around me, so this is the way that I prefer to do it. Anyway, now that that's on the screen and to scale, I select this curve drawing tool, and this one's different because it draws a line through the curve points as I dictate them, whereas this other one interpolates around the points. So the points are sort of like magnets that are pulling, and that's not what I want for this instance. So now that I've got the scale traced to scale, I can come out of this top view. So this is sort of like we're looking straight down on the desk with an orthographic projection. So there's no distortion happening from a camera lens. But if I go to my perspective view, I can select the lines that I want. I'm holding the Shift key down so that I can select just the outline of the scale. And then I can type the extrude, T-R-U-D-E, extrude CRV thing, and let's just extrude it 5 millimeters up. So I've got my parameters set to automatically cap it, and it turns it into this solid bar. And this is basically what I created when I made the jeans, the denim scales. But in that case, all I needed was the outlines because those were the trace to be cut with the laser cutter. So one thing to note here is how I'm treating Rhino kind of like I'm working on the desk, right? I just have a picture set down on my desk and I'm tracing it and then I'm pulling the shape up into 3 dimensions. And there's no sort of, they call them sketches in the parametric drawings programs. There's none of that. There's no sort of like external references that are dictating geometry in this. What you see on the screen is what you're working with. You can change the views to the top view or the front view or perspective, but it's all one desktop. So my workflow here is to copy things over, and I always copy them over a set distance. So in this case, 500 millimeters, so 50 centimeters over to the side. And now that I've got that, I've drawn up this surface, and I'll get to that in a second. And the idea is that I can just trim what you see there with the surface and get a nice, sculpted face to the scales. So how did I make this surface? I took the rough outlines, top and bottom of the scale, and then I offset these lines. It's an offset command. And let's offset it by, 10 out to here, and then the same with the other one. Then I did some editing to these control points, deleting some of them and just smoothing them out. This is where the real value add happens when you're doing surfacing. As the saying goes, lines are expensive, surfaces are cheap, because once you've spent the time to generate your lines, the surfaces follow pretty quickly from the lines. So those two lines highlighted in yellow were my final geometry. And then I developed this sort of arching curve at the front and the back. And I used the sweep to command, which basically says, these are your two railroads. This is the shape that goes along those railroads. And whatever the railroads do, the shape morphs and changes so that the two ends are always touching the rails. Using that technique, I was able to generate the geometry up to this point, and then I extended it. There's an extend command, so I just sort of stretched the geometry using the rules that I'd already dictated to give me a little bit of extra tail to hang out past that last line where I had to cut off. Here in the top view, you can see the U and the V lines that I talked about earlier in the video, and they get real close together and slanted up here. But I didn't know that was going to bite me yet, so this is the geometry that I created. And for this step, I have to go back to Rhino 7 because the functionality is a little wonky in Rhino 8. They did a large change to their code base for Rhino 8, so I don't know if they updated this functionality yet. It'll probably be fixed by Rhino 9. And anyway, like I said earlier, all the previous versions function flawlessly, so it's really no big deal to jump right back into Rhino 7 and just Control-C, Control-V. So I paste the geometry here into Rhino 7, and that allows me to make the texturing happen only on that surface on the inside there. But you can see what I was talking about, the curved sort of morphing. See how the lines are sort of 45 degrees here at the back end, but up there they're practically vertical, and they're kind of, the shape of them changes. And it just, to me, it doesn't look right. It doesn't look right. Back in Rhino 8, I took the surface that we were working with, and I chopped it in straight lines, top and bottom, that are parallel straight lines. And then I took and made a series of, these are planes, infinitely thin planes. So you can see those U and V lines, those are called the isocurves, but those are not the ones that I want to work with. So if I intersect those two surfaces, you can see the yellow line there is the actual surface that I want to deal with. But if I then look at the points, there's too many points. So I can rebuild that to have only 5 points, which is nice and clean. That's what I want. So this is what I'm left with, 10 lines that all have 5 points, and everything's going to be very clean when I loft these. You can see the U and the V grid is very regular, and things are going to be quite clean. So I generated this geometry here using that new surface. You can see this pipe that I've laid, and that's just a command pipe where it draws it around a curve. So that was easy enough to do. I subtracted the space that the pipe occupies from the overall scale there, and you can see the little groove that it leaves in the top of the scale. So exporting this part to Rhino 7 now gives us the much more regular crosshatch pattern. So that is how I achieved the carbon fiber PLA version that you saw, and it's a winner. It's really quite grippy, and it'll be quite strong. The final design with the black sticker inset on the yellow plastic was achieved using a command called offset. So offset surface. And you can see that's the direction that it wants to go in. And it's got a distance here of 0.7 millimeters. So it's almost a whole millimeter. And so that gives me a separate surface floating above the first surface. And so I was able to generate this whole surface there while using that first surface right here to be down inside of the pocket. You can see the stair step happening there between that surface and that surface. And I just used some fillets and some other fanciness to bridge the gap. So that goes to the 3D printer, but we still need the geometry to laser cut for the sticker. So I used a command called extract isocurve, which allows me to just pull one of the UV lines off the surface. And then I got it from right there, and I was able to pull a length off of that. And that's going to be 12.937 millimeters long. Now, if we look under here, we can see a line that I generated earlier. And that is a closed loop that maintains a distance of, I think, 3 millimeters from all of the holes and the edges of the geometry. Transferring this line work up to the surface above is how I was able to generate the pipe. And to accomplish that in Rhino, you use a tool called project. So this geometry here could be the sticker, the actual sticker. It is flat, it's ready to cut, that's the outline. But if I get a distance here, that's only 12.823. Whereas the curved line, which has to travel a further distance because it's going over the curve, is 12.896. So I figured it was about 0.1 millimeter of difference. So that 0.1 millimeters is pretty much that point right there. So if I take the outline here and I scale it from that point to that point and I stretch it to that point there, we're now just ever so slightly scaled and it should fit perfectly in the pocket. This is probably a little bit overkill. If there was a more extreme curve to it, this is something that I would need to consider. But in our case here, probably the flat napped geometry that we started with is plenty sufficient. And now that you know how the sauce is made, it's pretty easy to understand how I'm going to trace the outline of this pocket as well as the location of those two holes and add this geometry to the scales. And there we have it. There's the geometry for 3D printing the plastic scales, and for the textured sticker, this is the geometry for laser cutting. Taking this apart, we're going to see the order of assembly here, but the most important thing is that these scales are going to get flipped so that the screw holes, which are threaded and currently on the right side, will end up on the left side. Well, the other times I've installed the scales, this was the hard part. So you can see this is what's called a thrust bearing, and it's just the little ball bearing movement that gives the knife such a smooth opening and closing. So for the first one, you see I've got the post slightly installed, so there's a little lip for the first bearing to sort of like loop over. All right, I've worked the post in just a little bit past the bearing now, and hopefully I can just capture that hole on the blade. I might need to slide the lock out of the way. There we go. Now the hardest part is getting this last bearing slid into place here. Well, I'm going to use the back edge of this scalpel. Yep, I can see both the bearings are in line. So now if I can just... By the way, you're going to need a Torx bit set with some very fine... And there we have it, the first left-hand clip Ozark Trail 7.5-inch folding knife on the internet. And doesn't that look just so much better than the stock version. I think I like the green outline even better than the yellow. Yeah, it would have been nice for Ozark Trail to give you, ambidextrous, switchable clips. But hey, it's just a problem to be solved with a 3D printer. So you can see mirror image of each other. We got the left-handed clip fully installed, and it's working great. Let's put the yellow scales onto this unopened knife here. The blade is reasonably centered here in this one too, so looks like I lucked out and I got two very good ones. Here's the trick when changing the scales. Replace the scale on that whole side. Then use, I don't know, like a drill bit or a large Allen or Torx wrench or something like that that's a similar size to the actual pin. And it can't be the exact same size because there's a flat in there. So something smaller but close to it. And use that to press out the pin because that will allow you to keep the ball bearings and the blade all aligned in their orientation, just like so. Flat part of the pin here goes down towards that tang. Test it for blade wiggle. In my case, there's a lot. Tighten this down, but don't over tighten it because what happens is the ball bearings will put little tiny dents in the scales, the metal portion of the scales, the liner there. The knife will still function, but the movement will not be nearly as smooth as it was right out of the box. Drop a little lubrication in there. And that is how you DIY a very inexpensive knife into being extremely stylish and as functional as anything on the market. I love this thing. It's awesome. Let's talk about the left-hand clip version. You can see as I draw it from the left-hand side, my hand is already in position so that I can just slide my thumb up it and deploy it, ready to go. And then, of course, pull the crossbar slide and retract it, stick it back in the pocket. As this sits in your pocket, the blade, which opens there, sits up against the far edge of the pocket, so the blade cannot accidentally open when you're like sticking your hands in your pocket. If you kept it in your right hand pocket with a left hand clip, what could happen is the blade could open a little bit, and as you stick your hand in there, you could gouge yourself on the blade. So this is not meant to be carried right here, but you can carry it in your back pocket up against the edge. So there's two reasons to want to switch to a left-hand clip, which, the stock version doesn't give you the ability to do. The only drawback to this is that when you draw it, you will have to switch your hand, the grip, to be able to deploy it with the thumb stud. So there's reasons to carry it in your back pocket if you don't want to scratch your phone or something in your front pocket, something like that. But it's not as ideal for deploying. It does take a little bit of an extra movement if you want to quick deploy. And for all of my fine listeners out there in Radioland, here is a little gift for you. On thangs.com, all of the geometry that you would need to make your very own D2 Walmart Special Ozark Trail folding knife with fancy schmancy 3D printed scales. So we can see here in the folder, link in the description, is several versions. If you will be printing up the stickered version, meaning the inset texture sticker, then you will be needing to get the geometry for the sticker itself. And that can be obtained in one of two ways. First of all, if you are laser cutting the sticker, then download this file here and choose left hand or right hand. That includes the DXF outline for the sticker. But if you will be cutting out the sticker by hand using an X-Acto knife or something similar, then download this PDF file. And what you do is you spray some spray glue or glue stick or something like that, and you adhere this to the back of the texture. So from the back side, you cut out all of your shape, your shape here, and then it should have the perfect outline to fit into the pocket on the scale. If you found this helpful, I would really appreciate you pressing all of the good buttons down below. At the very least, hey, donate $1, 99 cents, 50 cents, I don't care. Donate a tiny little bit that you'll never even notice every month, right? Just go to my Patreon and send me that tiny little amount. It really helps me to keep making videos like this. Thank you so much for watching. See you in the next video. Have a great day. Bye.
I'm the YouTube algorithm. You should subscribe to Design Prototype Test, ring the all bell and become a fiscal supporter by clicking on the links. As your benevolent overlord, I'm telling you that it will make your life better. Rather than allowing me to keep force-feeding you mass audience, vacuous content, you'll actually be shown the interesting stuff that most people miss.